Hello everybody, welcome back to another episode of Classic Arcade Repairs. Today I just got out a out of the box Atari football PCB. And just getting it out and looking at it, it's definitely got some edge connector problems. I'll have to repair the edge a little bit and just clean it up a little bit. This side isn't too bad. There's a heat sink on this chip for some reason. Sound amp gets one for sure. It looks like we got our original regulator. Original sockets. At least this one has the ROMs instead of the bipolars. That's nice. Yeah, so. Alright. Well, I guess first things, let me fix this edge. Clean the edge up a little bit, and then we'll plug it in and see what it does. See if it comes up. Alright, I did a repair up on that trace. Oops. It's just a wraparound, copper wraparound trace. I got this thing hooked up and plugged in. I measured 5.02 volts across the 5-volt rail, which is good. But we're getting no picture. Nothing. So the first thing I will do is probe around the CPU. And see if it's doing anything. See if we're getting anything. So we'll go ahead and do that. Nothing. Alright. I'll go ahead and get my logic probe out and start. Actually, I'll just probably fire up my scope and use that. I use that thing as a logic probe, to be honest, so I'll go ahead and do that. Alright, right off the bat, first thing I see when I probe reset is it is stuck low, and if I hit reset, it's not doing anything. It's not popping back up. It's not that. We have a reset problem. I believe this is the reset counter. So anyway, yeah, I have to look at the reset schematic. I think it's this guy right here, 7490. So I will take a look at the schematic. I'll be back. Alright, I just looked at the reset counter in the schematic, and it's this guy. And just as I had thought, this is supposed to have 128V on pin 14, and we have nothing on pin 14, so there's no clock to this thing, so it's not going to do anything. So if we don't have 128V, those are our sync signals, so I need to find the sync counters, and I'll look for that in the schematic, all of my 161 sync counters basically, and I'm sure we've got probably one or two of them dead, if not more. So let me find those and I'll be back. Okie doke. I replaced the 161 that was bad, and we have our 128V now, and here's the reset. So we are resetting, and we're just kind of doing this. So I don't think I got test hooked up, do I? No, I don't. Or maybe I do, but it's just not. It's not doing anything. Yeah, so we could have bad RAM. We could have these ROMs could be no good. The sockets. These things got issues. So let's go ahead and I think I would like to just go ahead clean this board because it's pretty dirty. Let's clean this thing up so it's nice and pretty. And I want to replace these sockets. And then we can put it back together and I can put the fluke on it. And that'll tell us basically everything we need to know. So let me go ahead and do that. Alright, I've just taken chips out and I removed this ROM. And this guy is a disaster. So it ain't going to run with that thing in there. So I'll take these two guys out. I'll have to probably burn new ROMs, at least one. Hopefully these two are good. So we'll see. Okay, I have replaced the sockets. And I just so happen to have a working Atari football board right there. So I pulled the ROMs out of that and my CPU. And we're getting what looks to be the same thing. So now I'll be able to put the fluke on this. I've got good ROMs. I know these ROMs are good, so I'll be able to test the ROMs good. And all the RAM and all of that. It's probably got bad RAM and stuff on it, so that'll be next, is get the fluke out. Alright, I got the fluke out. And if I just do a bus test, it tells me data bit 0 is tied high. So it won't drive low. Data bit 0 tied high. Loop. Yeah, why not? Actually, let's do a write to 0 FF loop. Okay. So I should be seeing 1-1 on all of the data ins. And that is floating. That's high. That is low, not going high. I'm confused as why it's telling me that data bit 0 is tied high when it's, I mean, floating is going to be high. It's going to, you know, but if I do a, let's try to write at 0, let's try to write 0, 0 and loop that. Now is it driving these low? No, it is not. It's still just floating. That's why, maybe that's why it's saying it's tied high. And that one's floating too. That one is high. That one's low, but it was low all the time. That one's high. And this thing is enabled. This 244 right here doesn't really seem to be doing anything. So I think first things first, we're going to have to replace that guy. Because that, I looked at the schematic and that is the data buffer out to the board, basically. So yeah, and that the bus test is trying to drive this, and it can't. So we're gonna have to replace that guy. I'll be back. All right, very interesting. I just cut this guy out, turned it back on, and tried my test, and it still says data bit 0 tied high. So let's do our right at 0 FF 00 loop. And it's the same, it looks the same. Huh, okay. So, I gotta find out why data bit 0 is tied high. What is D0 tied to? Is it directly connected to these RAMs? I don't know. Or these RAMs. I have to look at the schematic. D0, wherever it's connected, is not good. So I'll check the schematic and I'll be back. Okay, I'm having a heck of a time with the data bus being corrupted and saying it's pulling stuff high or data bit tied high or whatever, and it doesn't make no sense to me because I have everything attached to the direct data bus removed, and the only thing that was really remaining were the RAM here that were on the buffered data bus, if you will, and they were still attached to the address buffer. I removed the address buffers. I removed everything off this board, and there was a bunch of rusted chips on here that I cut off, and the legs were basically falling apart on those things. So anything that's really rusted, I'm removing from this board. There's still a couple on here that are pretty rusty that I'll end up removing, but I just pulled all of the RAM. I desoldered because I wanted to test them. So I do like 4 legs on this one, 4 on this, 4 on this, 4 on this, and then I just do them in cycles like that so that I didn't overheat these, because you know, you don't really ruin these by desoldering unless the only way I would see that you would ruin them is if you go one leg at a time like this, all the way down this way and then all the way down this way. I don't do that. I do like 4 and I jump around, and then I go to the next one, I do 4 and I jump around. I never do 2 legs next to each other. So I make sure I don't overheat them anyway. And I've removed countless RAMs that way, and it never ruins them. This thing had 7 out of 8 RAMs bad. These are all no good. One good one right here. That's the one good one. The rest of them are no good. So that's very interesting. 7 bad RAMs. So I guess it's time to start doing some repopulating on this thing. And it's going to need some new RAM, that's for sure. Alright. Alright, I will be back. Okay, I have my good ROMs in it. I know we're good, and the fluke on it. I've cleared all the holes for all the rusted junk that I removed, and I'm still getting, if I do an auto test, I'm still getting bits bad. And there is no way I should be getting bits bad, because nothing is tied to the data bus. Nothing. The only thing that is tied to the direct data bus, and when I say direct data bus, I mean, okay, let's, I don't have it up on my computer, but, okay, you'll see the CPU, the data is driven out to various parts of the board through a 244 buffer. But there is also, before that buffer, those data bits also go to these. They go to these ROMs, That's it. That's not it. There's a couple, maybe a 374, a couple 244s or whatever, that are directly tied before the buffer to the CPU. Those are all removed. Everything that is tied to that is removed, except for these guys. But I know these are good. And I've beeped out these traces. Nothing is shorted, nothing is tied. If I loop this, I got to thinking, this thing just must be out of sync. It's the only explanation, is this thing is just not synced properly. Well, I've got a 161 jumped over one of the horizontal counts. And if I mess with it just right, let's continue to mess with it. It'll straighten up here in a second. See that? Loop. It reset. Come on. Yeah, it's not wanting to do it now. I can't really do it holding the camera. Let me come right back. Alright, I've been doing some just general probing around and looking around on this board. And I have so far found 1, 2, 3. This one is hot. I mean, you can't touch that. That's 3 so far. What I want to do is, and there's a lot I haven't even looked at. There's probably more bad on here. I guess I should, I don't know, maybe I should just go through all of these simple gate chips at least. But I kind of want to just stop and repopulate because I'm having to use my logic pulser a lot to pulse signals into these to test these because there's so much missing on the board. So I think I'll go ahead and, oh, there is a 42. I was looking, there's another 42 up here. That's, I would imagine it's probably good. I checked this one down here and it was fine. Yeah. I don't know, there's some 174s and 175s on this board. I think I would like to test as long as they have signals coming into them. I'm on a 175 right here, which is right here. It's this guy. I kind of wanted to look at that, although I think that's fine. You never know until you look, though. But so I will go ahead, and I'll probably poke around just a little bit more, but at some point I do want to repopulate this board. But I'm sure there's more bad stuff on here, so I would like to eliminate that. So I'll do that for a little bit longer. And like these 253s down here that are using muxing, you know, RAM data and all that, I can't do nothing with those until I at least have the RAM and stuff back in the board. So yeah, we'll do that. I'm just going to continue looking around a little bit, and I'll come back later. Alright, I'm looking at that 175, and you can see up here I just got it running free, and it's working right as it should. You got the clock up top, you know, data input on the second line, and then we've got the 4-bit Q output and 4-bit not Q output on the bottom there. So the Q and Q not obviously are inverse of each other, and you can see they are. 2 and D are opposite, A and 5 are opposite, E and 1 are opposite. So this thing seems to be working fine, the 175. But I'm looking at this 139. I just glanced over and I saw it and I was like, I wonder what that's doing. So I took my probe here, and you can probe the first 3 inputs. This is the enable, and you can see it is being enabled, so it should have something going on. This is one of the inputs, this is the other input, and then our outputs are all stuck low. That's not possible. These rest high and they drive low. And the other side, this is the enable. You can see you do get an enable pulse in your inputs, and here are our output bits. You can see that one's not much. That one's not much. They're all low. So this is a 139 that is absolutely no good. Red dot. So I'm just continuing on looking around. The 175 survives, but that 139 is dead. Dead as a doornail. So we'll move on. This thing has a handful of 174s, but they are National Semiconductor 174s. I really concentrate on these really old rusty chips like this. These 164s are, I'm just going to replace those. I don't know if they're good or not. They're just rusted out. Anything super rusty is going. Here's another 164 that's all rusted out. That's going to get replaced. So I've got enough bad stuff I've found on here, so I think what I'm going to do is I'm going to cut anything that's super rusty out, like those 164s I just pointed out, replace these bad chips, repopulate, and see what we get. A lot of work on this guy. Okay, I have this guy all repopulated, and I've got the fluke on it, and we can now do a bus test. Oops. No tied bits. And I don't know what the ROM stuff is, but RAM I believe is 03FF, and we're working there, it looks like. Good. And I don't know, I think the other RAM might be 400 to, I really don't know. Let's just try FFF. It might be 2000, RAM at 2000 maybe? 2FFF? I don't know. I don't know what that, I'm going to have to pull up the fluke info and find out what this RAM range is, because if I just run it, you can see it's really goofy like this. So we still have an issue with something, but I do want to, what is this range? I bet you some of these are bad. I bet you these 250, I can test these now. I can now get on these 253s and analyze all of those, and that's what I want to do first and foremost, because that is access to these RAMs. So I'm going to make sure that the hardware is accessing these, the CPU can write into these. So let's go ahead and get the analyzer on all of these 253s. Alright, I have found a bad chip here. This is an LS83, and I'd like to just kind of try to clean the contacts. You can see here we have, let me move this. This is an adder, and you're basically adding the top 2 lines for the output on the the sum on the bottom. Here we have 6 and 10 is 17. That's not right. 6 and 0 is 6. 6 and 8 is not 15. 6 and 0, 6, 6, and 10. Here we have 16, which is right. It's right most of the time, but every now and again I see where it is not right. See, it'd probably take me here. 14 and 6 is not 21. 14 and 5, it's got 20 and 21. So this thing's no good. And this is H5, that's this guy right here. It's this guy, and it is involved in graphics. Yeah, so that's definitely not right. And there's this one right next to it I have already looked at, and that one was fine. So this one is not good, and there's one more which is right here. I'm going to go ahead and just move this up and check this guy out right there. But we'll see. But so far I've got one that is not good.